Hello, Year 11. Back again. This video that I'm making here is made, as it says on screen. It says this video is made to cover 3 exercises from our textbook. We've got exercise 14b, defining circular functions, sine and cosine. Exercise 14c, another circular function, tangent. And exercise 14d, reviewing trigonometric ratios. Now, exercise 14d is actually very, very short. There's only the one question with about 9 parts to it, and it's really just a redo of Year 9 maths. Okay, so it's not, I mean, why it's actually a separate exercise, I'm not sure. So what I'm actually going to do is I'm going to go there first and just cover what's in 14d, because I think that's actually going to make it easier to explain 14b and 14c for you. Okay, so 14d is actually about trigonometric ratios here. Okay, now you should remember this. This is not new mathematics for you. Okay, and trigonometric ratios actually relate to a right-angled triangle. Okay, so we've got a right-angled triangle drawn here. Okay, this is sort of a mirror of the way we usually draw them. Usually I draw them with the right angle on this side, but anyway, it still works. So this is our angle that we're considering, and if this is the angle we're considering, that's the opposite side. Okay, that's the side opposite to the angle. This is the side adjacent to the angle, remembering that the word adjacent means next to, so it's next to the angle we're considering. And this obviously is the hypotenuse of the triangle. Okay, it's the longest side of the triangle, and it is the side directly opposite the right angle. Okay, nothing new here. Now I've written on this piece of paper here the trigonometric ratios SOHCAHTOA. Okay, everyone should remember SOHCAHTOA. Simply, if this is our angle A as it's defined here, the sine of the angle A equals the length of the opposite side divided by the hypotenuse. The length of the hypotenuse. The cosine of angle A is the length of the adjacent side divided by the hypotenuse. And the tangent or tan of angle A is the length of the opposite side divided by the length of the adjacent side. So because it's a length divided by a length, the units of measurement cancel out, and the number is unitless. Okay, and it's unitless, and it's why we call it a ratio. It's a ratio because it's one number divided by another, and it doesn't have a unit. Okay, so sine, cos, and tan are the trigonometric ratios SOHCAHTOA. And in exercise 14d, there are some simple questions there where you have right angle triangles and you have to find the value of the pronumeral. So a couple of the questions are asking you to find the angle, and a couple of the questions are asking you to find the length of the unknown side. Okay, that's a rehash of Year 9 maths. You should be able to do that. They don't even have a worked example there in the textbook. Okay. If you need help with that, just ask your teacher to go through 1 or 2 with you if necessary. Okay, but it really shouldn't be necessary at Year 11 level. Okay, going from there, I want to go to, as I've got it here, exercise 14b, defining circular functions, sine and cosine. Okay, so for that I need this picture. So what we have here is a unit circle, which you should recognise by now from the previous exercise. So we have a circle with a radius of 1, and the centre of the circle is the origin of the Cartesian plane. So this value here for x is 1, this value here for x is negative 1, this value here for y is 1, and this value here for y is negative 1. Okay, now there's an angle being drawn here in the first quadrant. Alright, out to the circumference. Okay, and some coordinates have been written here. Cos theta, sine theta. So when you define, when you have a unit circle and you draw an angle at the center of the circle, where the coordinates of the point that's touching the circumference of the circle represent the cosine and the sine, cos and sine of that particular angle. So this value here, the x coordinate, is the cosine of this angle, and the y coordinate is the sine of this angle. Another way of looking at that is that, well, actually, because the trigonometric ratios exist, so for this angle, okay, the sine of this angle equals this length divided by the hypotenuse. Okay, So sine equals opposite over hypotenuse. Okay, but in this case the hypotenuse is 1. So in any ratio here you're dividing by 1, or in the sine and cosine ratios you're dividing by 1. And if you're dividing by 1, it simply means that the sine of this angle is actually just this length. Okay, and this length is going to be some value less than 1, because the longest length you can get inside the circle is 1. So the sine of the angle is this length here, and the cosine of the angle, cos of the angle, is this length from here to here. Because what we've done, by the way, is we've created a right angle triangle here inside the unit circle. Okay, so we've got the coordinates. These coordinates, if you have them, it's cosine, sine. If you don't have them, or to conceptualize that, sine represents the vertical length, cosine represents the horizontal length, and the sides of this right angle triangle. Okay, and put simply, that's about it. That's about it. So I'll just duck back here and take a quick look at the exercise. Okay, because what they're actually going through here in the exercise is explaining what the sine and the cosine of some common angles, or what some common angles in radians are. So if we remember, okay, this angle here from the center to the circumference there, that's an angle of 0. Okay, so that's 0 radian. Now remember that a full circumference, 180 degrees represents an angle of pi radian. Okay, and an angle of 90 degrees represents pi on 2, or half pi radian. Okay, 270 degrees, so if you go all the way around here, that's 270 degrees. That represents 3 pi on 2 radian. Okay, now what we're looking at here is, okay, what's the sine, if you like, what's sine of 90 degrees? So if we draw an angle from here to here, let's get a pencil out and actually draw it. Well, you can see it's the axis, right? So if I draw that there along the axis, it's making an angle of 90 degrees all the way around. Okay, so the sine of pi on 2 is 1. It's the radius. Okay, so let's write that here. Sine of pi on 2 equals 1. Okay, and what's the cosine? Cos of pi on 2. Well, it's the horizontal component, and there is none. So cos pi on 2 equals 0. Okay, now if we go round here again, what's the sine of pi? Sine of pi, that equals 0, because if you go all the way around here, there's no vertical component. Okay, but the cosine of pi, cos pi, equals 1, because it's all horizontal. It's all horizontal. Okay, and if we go to 3 pi on 2, okay, so if we draw an angle all the way around here, what's the vertical component? It's -1. It goes from 0 to -1. And you may not be able to see that actually, I've just realised. And then cos 3 pi on 2 is 0. Okay, so when you look at the questions in the exercise, it's actually just asking you to evaluate and find the values for sine, cos and tan of those fractions of pi. But some of them are actually negative. Okay, some of the values you've got are negative. Okay, so in that respect, what you need to be looking at is you need to be looking at, well, what direction around the circle are we going? Okay, so if we start here, so we're drawing a radius from the origin to this point here. All right, if we want to draw a positive angle, if we have a positive angle, we go up to here. Okay, so this is approximately where they've drawn that in. That's basically pi on 4. Okay, but if I go back the other way, this angle is 3 pi on 2. Okay, but it's also negative pi on 2. Alright, it's negative pi on 2 because I'm going back this way. Okay, now this is pi, but it's also negative pi. We don't tend to worry about that. Okay, this is pi on 2, it's also negative 3 pi on 2. Okay, so we can have positive and negative values there. Right. But to recap, the values of cosine or cos and sine represent, sine represents this vertical length here of this right angled triangle drawn in the circle, and so that's sine, that's cosine. Okay, now interestingly, what I'll do is I'll draw an angle here in this quadrant. Okay, so I'll draw that in there. Now just imagine that I've started here and I'm coming all the way around. So we're coming all the way around to there, and that whole angle there is theta. Okay, so that's theta there. Alright, when we draw sine, let's pick a different colour. Let's get a red pen out, see if that shows up nicely on camera. This is sine theta here, if that's theta, okay, that whole angle there, and then this length here this is cos theta there, okay. Now in this quadrant, this is positive because it's going up from 0, so this is positive, but the value of cosine here is negative. So what angle is this here? So this is this is 1/4, 1/2, 3/4. So I'm going to say this is approximately, let's for argument's sake, let's say this is 3 pi on 4. Okay, 3 pi on 4 is there, 3/4 pi is there. Sine of 3/4 pi has positive value, but cosine of 3/4 pi has a negative value. Okay, that's the sort of thing that we have here in our unit circle. Okay, in our unit circle. That's the basics of sine and cosine. What we want to move into here is also another trigonometric ratio, which is tangent. So just to recap there, another trigonometric function. Exercise 14c, another circular function, tangent. Okay, and for tangent, we need a different picture. Okay, so this is a similar picture to the one we've had before. We have our unit circle. Okay, we have 1, -1, 1, -1, 0 in the middle. Okay, we've got an angle drawn in the first quadrant here. We've got the length here, cosine, in black. Okay, so that represents cos of this angle theta. That length there represents sine of this angle theta. Okay, but to get a representation of tangent of theta, tan of theta, what we have here is on the right of the unit circle, and it's always drawn on the right. Okay, we have a tangent to the circle drawn. So this is also a right angle here. Okay. Okay. So, but we have a larger triangle. We have this big triangle here. We've got the green line here. This is our opposite. Okay, So opposite. Okay, and here we have adjacent. Okay, now remembering that tan of theta equals opposite over adjacent. The length of the opposite side over the length of the adjacent side. Okay, but in this situation, the adjacent side is always 1 because it's a unit circle. That's why we use the unit circle. So what it means is that the tan of any angle is actually the length of this line. Okay, and that's why that's been drawn in green there. Okay, the tan of the angle is the length of this line. Okay, now what you'll notice is that when we look at trigonometric ratios of angles, for any angle, sine of the angle is a value less than 1 because it's inside. It's either 1 is the maximum value. So the maximum value of sine is either 1, or the maximum magnitude of sine is 1. It's either 1, it can max out at 1, or it can max out at -1 down here, min out if you like. Okay, and the same for cosine. The maximum value of cosine can be 1, or it can be -1. Whereas the value for tangent is, there's times when it's undefined, we'll get to that, but value for tangent is greater than 1. Okay, it's greater than, it has a magnitude of greater than 1, shall we say, but it can be negative. Let me show you that. Okay, so it's easy to see in the first quadrant that the tan of an angle is that length there. But if I come through and I draw an angle greater than 90 degrees, so I'm going to come in here, okay. If I draw an angle in there, alright, so if I draw that angle in there, then sine is this length here, cosine is this length here, okay, so what it is it's this angle all the way around, okay. So if I do that there, let's say I use that symbol there, okay, then sine, this is sine, oops, didn't quite draw it the same, this is cosine, cos, okay, but tangent's not over this side, tangent is still over here. So to get tangent, I have to extend this line out to here. Okay, so that's there, which means tangent of the angle is this length here, from there to there. So let's straighten that up so you can see it. Okay, tangent of this angle that I've drawn in here, there, round to there, okay, is that length there, because we go back to the tangent that's on the right of the unit circle. So this has a negative value in this case. Okay, it has a negative value. So we've been able to find values for sine, cosine, and tangent. Okay, now in that regard there, you can use a CAS calculator to find these values. Okay, and when you do use a CAS calculator to find these values, you need to make sure that your calculator is in radian mode. Okay, up to now we have been using our calculator in degrees. So I'm just turning this on here. I don't know how clear that is for you, but that's in there. Okay, now to get our calculator in radian mode, we go to settings, which is 5. Okay, and we can go to document settings. Alright, now actually this is already in radian here. We've got display digits flat 6 and we've got radian. Okay, can you see that? There, you can see that there now. That's in radian. If it's in degrees, change it back to radian. Okay, because what we can actually do here is we can say, okay, well, let's find the trigonometric ratio of different functions. Okay, so we'll go to, I'll just make a new one. No, I don't want to save what's already there, and I want to add a calculator. Okay, so we have a button for trigonometric functions. Okay, and it's that one there. Next, it's underneath control, so I can press trig, and you've got sine, cosine, tan are the first 3 there, and there's others. There's cosec, sec, cot. I'll have to look up at cot. I'm not sure what that is. Then you've got inverse sine, inverse cos, inverse tan, inverse cosec, inverse sec, and inverse cot. Okay, cotan. That'll be. Sorry, cotan. Don't worry too much about cosec, sec, and cotan. Okay, but we've got sine there. So if I do sine, and I do sine of pi on 2, say, if I want to know the sine of pi on 2, then, whoops, wrong button, I need control book, there's pi over 2, can you see that? Yep, and we hit enter, and it says sine of pi on 2 is 1. Is that true? Well, let's have a look. Okay, pi on 2. Pi on 2 is up here. Remember, this is pi. This is pi on 2. So pi on 2 would be 90 degrees. Yep, so the sine of pi on 2 is 1. And the calculator will do that because it's in radian. Okay, now, good thing about these unit circles is that you can keep going around. So, round there is pi, round there is 2 pi. If I go round again, I get to 3 pi. That's another half circle. So that's 3 pi. Okay, that's 4 pi. 2 revolutions is 4 pi. 3 revolutions is 6 pi, and it's multiples of 2 pi as you go around. So if you ever get asked, okay, what's the sine of 3 pi? You can say, well, okay, that's 1 pi, that's 2 pi, that's 3 pi. The sine of 3 pi is actually 0. Okay, getting a little bit advanced there. Alright, but that comes in to things like question 3 in exercise 14c. It says, okay, for each of the following values, find tangent of, say, 720 degrees. Okay, or the tangent of 180 degrees. Now 180 degrees is over here, 360 degrees is 1 full revolution, 720 degrees is another full revolution. Okay, so it's 2 revolutions, so it's the same value as 360, which is the same value as 0. So the tangent of 720 degrees is undefined, it's 0. Okay, so there you go. Look, I think I've given you enough there to go on to have a look at these exercises, but by all means ask your teacher questions if you have them, but we'll